Hello, welcome back. Today we're going to be talking about representing functions as rules and tables. By the end of this video, you should be able to determine if something is a function, find a function's domain and range, make a table for a function, and write a rule or equation of a function from a table. We have some vocabulary. A function is, or rather tells us that for every input, there is only one output. So something is a function if every time you put something in, you get only one thing out. So with these things called functions, there are inputs and there are outputs. Something you're going to put in, something you're going to get out. Inputs are typically x's, or they're called the independent variable. Output are typically y's, and they're called the dependent variable. Domain. Domain's all of your inputs, and range, well, range is all of your outputs. Domain is also all of your x values, typically, and range will be all of your y values, typically. Let's take a look at a couple of examples. On our left-hand side example, we have a table, and our table contains x's and y's, or inputs and outputs. Our x's are -7, -2, 4, and 6. Our y's are 4, 4, 5, and 8. So if we were asked to find the domain, all we would do is list the numbers in the input side. So we would list -7, -2, 4, and 6. Our range would be the y values. 4. If a number repeats, you do not have to list it twice, so it's 4, 5, and 8. So they're just the numbers you find on the y side. Is this table an example of a function? Well, it is if all of the x numbers go to just one other number in the y side. In other words, does -7 only go to 4? Well, yeah, it does. It doesn't go to any other number. Does -2 only go to 4? Well, yeah, -2 goes to just 4. What about 4 to 5? Yes. And 6 to 8? Yes. So is it a function? Well, yes, because all of the x's go to just one y. Why don't you write the domain and range for this mapping right here? Those little two bubbles are called a mapping. And in a mapping, your inputs are on the left, and your outputs are on the right. You can just follow the arrow from the input to the output. Go and find the domain and range and determine if it is a function or not. Okay, your domain was 4, 5, cow, and 6. Your range was 12, the number 456, chicken, and 5. Is it a function? Do all of the numbers on the left go to just one number on the right? Well, yeah, 4 goes to 12. 5 to 456, cow goes to chicken, and 6 goes to 5. So is it a function? Yes. Y'all, something can be a function even if it doesn't make a lot of sense. It's just a word that means every number that you put in, or everything you put in, you better get only one thing out. Let's take a look at another example. On the left-hand side, we have our inputs, 1, 3, 4, and 1. So that would be our domain. 1, 3, 4, and 1 you don't have to list twice. Our range are our outputs, 5, 7, 6, and 4. If you want to, you can write it in numerical order, 4, 5, 6, 7. Is it a function? Well, no. Why not? Well, the number 1 in our input side goes to the number 5. But our number 1, same number 1, goes to 4. So since the number 1 goes to two different numbers, one goes to 5 and one goes to 4, it is not a function. Let's take a look at the other example. Let's go and list the domain. -5, 0, 1, 2. Your range, -5, 2, and 7. Is it a function? 2 goes to just one number. But 5, notice the 5's got arrows going both to the negative 5 and the positive 2. So since we have an input going to two different outputs, it is not a function. Here's a couple of examples for you to try on your own. Go ahead and press pause, and when you're ready to see the answer, press play. Alright, on that first one, domain. Your domain are all of your x values, or your inputs, negative 1, 0, 1, 2. Your range are your outputs, negative 1, 0, 1, 2. Is it a function? Well, sure. All of these numbers on the left-hand side correspond or go to just one number on the right-hand side. So, yes, it is a function. Let's look at the right-hand side. Look at the mapping. Is it a function? Well, it's its domain, 1, 8, 9, and 12. The range, well, there's only one number. It's negative 1. Is it a function? Yes, it is. Why is it a function? Well, let's take a look. Our inputs better go to just one number each. 9 goes to negative 1, 1 to negative 1, 12 to negative 1, and 8 to the negative 1. Notice, none of our inputs go to two different numbers. Every one of them go to its own number. So it is a function. An easy way to remember that is if your inputs repeat, or your x values repeat, it's probably not a function, so long as your inputs go to two different outputs. We're on to our next objective, which is to make a table for a function and then identify the range. So the function we're given is y equals 2x minus 5. That's for the function part. Notice y is a function of x because y is by itself. And our domain is negative 1, 0, 1, and 2. So we need to fill out this table so we can find the range. Well, you'll remember domain stands for the x values or the inputs. So our inputs are negative 1, 0, 1, and 2. I've added a row in between the x and the y that typically is not there to help us go ahead and find the y values. Notice, y is equal to 2 times whatever x is minus 5. So if x is negative 1, y is equal to 2 times negative 1 minus 5. 2 times negative 1 is negative 2 minus 5. Negative 2 minus 5 is negative 7. So if x is negative 1, y is negative 7. Next one. If x is 0, y is 2 times 0 minus 5. 2 times 0 is 0 minus 5 is negative 5. So our y is negative 5 if x is 0. What happens if x is 1? It's 2 times 1 minus 5. 2 times 1 is 2, minus 5 is negative 3. If when you're filling out these tables you notice a pattern on the y's, because the x's are following the same pattern on top, x goes up by 1, so the y's are going up by 2, we can actually skip finding the process to find the y by just adding 2, negative 1. Or you can go and fill it out. 2 times 2 minus 5. 2 times 2 is 4, minus 5 is negative 1. So if x is 2, y is negative 1. Our range are our y values, negative 7, negative 5, negative 3, and negative 1. Go ahead and try to make out this table on your own and press play when you're ready to see the answer. Okay, hopefully you filled in the x values as your domain, negative 4, negative 2, 0, and 2. To find the range, you would have put these x values in to find the y. By the way, y is equal to 1/2 x plus 1. So 1/2 of negative 4 plus 1. 1/2 of negative 4 is negative 2, plus 1 is negative 1. Next example, 1/2 of negative 2 plus 1. 1/2 of negative 2 is negative 1 plus 1 is 0. And our third one, 1/2 of 0 plus 1. 1/2 of 0 is 0 plus 1 is 1. You could see the pattern at this point, or you can go ahead and fill it out. notice we're going up by 1 every single time. If x is 2, y is 1/2 of 2 plus 1. 1/2 of 2 is 1, plus 1 is 2. So our range is -1, 0, 1, and 2. Now we're on to our next objective. You're given a table. Can you find the rule or the equation for this table? Let's take a look at it. Suppose x is -5. Well, y is -3, so -5 goes to -3. If x is 1, well, y is 3. I don't really see a pattern yet. If x is 7, y is 9. If x is 13, y is 15. So x is our input, y is our output. In order to write our rule or our equation, we need to find a pattern. What's being done to x to find y? Could be guess and check. Let's take a look. Suppose to go from -3 to -5 to -3, you just added 2 to your x. -5 plus 2 is -3. Let's see if that works for the next one. 1. Can we just add something? Sure, we can add 2. 1 plus 2 is 3. 7 plus 2 is 9. 13 plus 2 is 15. So there's a pattern. We can add 2 to all of our x's to find our y's, but how would you write an equation? We know it's going to be y equals. What do we do to our x values? Well, we take our x values and we add 2 to find our y's. So you would write just that. Your x values and add 2. If you want to make sure your function rule actually works, just substitute in the x values to see if you can get out the y's. And there you go, there's your function. See if you can find an equation for this table. Press pause, and when you're ready to see the answer, please press play. Okay, let's take a look at it. 7 to 3. Well, that's a little weird. You definitely didn't add something. Okay, let's see if we can find a pattern. 10 to 6. 13 to 9. 16 to 12. Looks like you're going down every time. But by how much? Well, 7 to 3, you subtracted 4. Let's see if that pattern holds for the next one. 10 to 6. Let's see, you, well, subtracted 4. 13 to 9, subtracted 4. 16 to 12, subtracted 4. Oh, so our y values are equal to our x values, take away 4. And there's your function.